Today's video is on integration using residues. In today's video, we are going to find the poles and the residues of the function f of z is equal to z squared plus 2z by z plus 1 square into z squared plus 4. So here, the function value f of z is given as z square plus 2z by this is z plus 1 square into this value z square plus 4 can be written as z plus 2i into this is z minus 2i. So if you watch this one, this will be a plus b into a minus b, which is equal to a square minus b square. So this is z square minus 2i square. So I square is nothing but minus 1. So this will become z square plus 4. So I have, see here, made a factorization for this, that is z square plus 2z by this can be written as z plus 1 square into z plus 2i into z minus 2i. So in order to find the poles, see here, for finding the poles what we have to do, so we have to equate this denominator to 0. So here the denominator value is z plus 1 square into this value is z plus 2i into this value is z minus 2i to 0. So if I equate this z plus 1 square to 0, here clearly z is equal to minus 1 is a pole of order 2. So this is minus 2 for 2 times. Therefore, the order value is equal to 2. And if I equate this one, that is z plus 2i is equal to 0, then z is equal to minus 2i, which is a simple pole. So this is simple pole. And if I equate z minus 2i to 0 and z is equal to this is plus 2i, which is a simple pole. So this is a simple pole. Now we have to find the residues. So here our pole values are nothing but, so z is equal to minus 1 is a pole of order 2 and z is equal to minus 2i is a simple pole and z is equal to plus 2i is a simple pole. First of all, I am going to find the residue of the function. So here our residue value of f of z. How to find this residue? So residue of f of z at point z is equal to z naught is nothing but 1 by m minus 1 factorial into, see here, this value is limit z tends to z naught. This value will be d by dz power m minus 1 into this value is z minus z naught power m into f of z. F of z. So this is our formulae. So in this order is equal to 2. So if our order is equal to 2, order value means m value here. So m value is equal to 2 and z naught value, our pole value here is minus 1. So if I substitute in this formulae, then this will become, see, residue of the function, see here, residue of the function at the point z is equal to, see, this is minus 1. So residue of the function at the point z is equal to z naught. Here z naught value is equal to minus 1. So here our m value is nothing but 2 minus 1 factorial into this is limit z tends to minus 1. This value is d by dz power. This is 2 minus 1. So m value is 2 here. Z minus Z naught. Z minus, what is our Z naught value? This is plus 1 par M. What is our M value here is 2 into F of Z. So what is our F of Z value? So here our F of Z value is the question, that is Z square plus 2Z by Z plus 1 square into Z square plus 4. So I am writing the same thing here, that is Z square plus 2Z by this value is Z plus 1 square into this value is Z square plus 4. Clear? Now I can cancel this z plus 1 square in the numerator as well as denominator. And see, this is going to become, this is 1 by 2 minus 1 factorial is nothing but 1 by 1 factorial into this value is limit z tends to minus 1. This is d by dz. 2 minus 1 is 1 time. 1 time we have to make a derivative for the remaining function, that is z square plus 2z by this is z square plus 4. Again, this is of the form u by v. So in order to make the derivative of the form u by v, so here the derivative value is v square. We have to leave v for one time. We have to make a derivative for u and again we have to leave u and we have to make a derivative for v. So the derivative of u by v is nothing but v square by vu dash minus uv dash. So this value is u and this value is v. Now I will make a derivative for one time. See, this value is limit z tends to minus 1. So for making a derivative, we have to make v square. That is z square plus 4 whole square. We have to write v for one time, that is z square plus 4. And we have to make a derivative for u. So here, for making derivative for u, that is for z square, this is 2z, for z is equal to 2 minus, we have to leave u, that is z square plus 2z, and for v dash, so this value is nothing but 2z. And now we have to substitute z value as minus 1. So if I substitute z as minus 1, this will be minus 1 square. So this, so first of all, I am substituting z value as minus 4. This is 2 minus, this is plus 2. This is minus 1 square. This value is plus 1 minus 2 into this value is minus 2 by z value as minus 1, that is 1. Minus 1 square is 1 plus 4, this is whole square. And see, this value will be, this value is minus 1 square, this is 1 plus 4 into, if I cancel, this is 0, and this value is minus 1 into minus 2 by 1 plus 5 whole square, so which is equal to 25. 0 into anything is 0. This is 2 minus 2 by 25. See here, the value here is minus 2 by 25 for this. See, after making derivative, this will be z square plus 4 whole square, z square plus 4 for one time. If I make a derivative, this will be 2z plus 2 minus, so if I leave this u, that is z square plus 2z, and for this one, this is 2z. So after substituting minus 1, this is minus 1 square is plus 1, 4, and this is minus 2 plus 2, this value is 0, and this is 1. Minus 1 square is 1, minus 2, this is again minus 2, and see here, this is minus 1 square is plus 1 plus 4 whole square, that is 5 square, this is 25, this value is 2. Minus 2 by 25 is the residue value for the pole f of z. See here, for the pole of the function at point z is equal to minus 1 is minus 2 by 25. And clearly, for z is equal to minus 2, the residue value we got is minus 2 by 25. And next, for the simple pole, z is equal to minus 2. See here, for z is equal to minus 2, what is the residue value? For finding the residue value, so what is the formula here? Residue of the function, residue of f of z at point z is equal to z naught is nothing but limit z tends to z naught. This will be z minus z naught into f of z. So here our z naught value here will be minus 2. So residue of the function at the point z is equal to minus 2i is nothing but limit z tends to minus 2i. So here z, in place of z naught, if I substitute minus 2i, this will be plus 2i into the function value. So what is our function value is nothing but this one, that is z squared plus 2z by, this is z plus 1 square into z minus 2, z plus 2i into, this is z minus 2i. So this is z plus 2i, z plus 2i after got cancelled. So after substituting z value as minus 2i, so this will be minus 2i square plus 2 into, this is minus 2i by, this is minus 2i plus 1 whole square into, in place of z, if I write minus 2i, this will be minus 2i into minus 2i. So clearly, so this is minus 2 square is nothing but 4, and I square value is minus 1. So this is minus 4i, clear? And so if I apply a plus b whole square, so this is minus 2i square plus 1 minus 2ab, 2 into a into b, b value is again 1 into minus 4i, clear? So this value is minus 4 minus 4i by, this is 4i square. So this value is minus 4 plus 1 minus 4i into, here the value is minus 4i. So here this value is minus 4 minus 4i by, this is minus 3 minus 4i into The value here is 4i. So here if I take minus 4 common, this will be 1 plus I by, again here is minus 4i. If I take this one, if I write this as minus 3 minus 4i, so I can cancel this minus 4. And again if I multiply with the I here, so this is 1 plus I by, if I send this inside, this will be minus 3i, and this is minus 4. If I multiply, I square is minus 1, so this will be plus. So this value is 1 plus I by, this is 4 minus 3i. So if I rationalize it, so if I multiply with 4 plus 3i by again 4 plus 3i, and see what happens here. So this will be 1 into 4 is 4, and this is 1 into 3i is 3i. This value is 4i, and here if I multiply, I square is minus 1 by a plus b into a minus b is a square minus b square. So here 3i square, that will be plus 9. 3 square, that is 9, and I square, this is minus 1. So here what happens, this is 4 minus 3, this is 1 plus, this value is 7i by 25. See clear? So this is the value which we got, the residue value. So this is the residue value of f of z at point z is equal to minus 2i. So this is the most important question. See here, our value is 1 plus 7i by 25. And the next one, the residue value, the simple, for the simple pole z is equal to plus 2i. See, the next simple pole here is z is equal to 2i. So this one, now we have to find out the residue of f of z for the simple pole z is equal to 2i. For that, see, residue of the function f of z at point z is equal to z naught is equal to, this is limit z tends to z naught, this is z minus z naught into f of z. Here our f of z value is nothing but, our z naught value is nothing but 2i. Z naught value, residue value is nothing but plus 2i. For plus 2i, what we are going to do is, see here, residue of the function f of z at point z is equal to plus 2i is nothing but limit z tends to 2i, this value is z minus 2i into f of z. So what is our f of z value? So f of z value is this one, that is, so this one z square, this is z square plus 2z by, this value is z plus 1 square into z plus 2i into this value is z minus 2i. So after cancelling this numerator and denominator and substituting 2i in place of z, so this value will be 2i square plus 2 into 2i by, this value is 2i plus 1 whole square into this value is 2i plus 2i. So here what we have to do, so 2 square is nothing but 4 and I square is nothing but minus 1. So this value is 4i. So if I use a plus b whole square, so this will be a square plus b square plus 2 into a into b, and this value is again 4i. So this is addition here, and this value is nothing but minus 4 plus 4i by, a square is nothing but 4 and I square is nothing but minus 1. This is plus 1. This value is plus 4i into this value is again 4i. So if I take 4 common here, if I take 4 common, this will be minus 1 plus I, and this value is 4i here, and this is minus 3 plus 4i. So if I cancel this 4 and send this I inside, this will be minus 1 plus I by, this is minus 3i. If I multiply with I inside, so this will be minus 4. So if I take minus common from the numerator, this will be 1 minus I. If I take minus common from the denominator, this will be 3i plus 4. So if I cancel this one and make a rationalization, so after multiplying with, this is 3i minus 4, and again this is 3i minus 4, and see if I multiply, see what happens, this is 1 into 3i is 3i, and this is 1 into minus 4 is minus 4, and after multiplying, so this is minus 3. I square is nothing but plus 1. So if I multiply, this will be 4i by a square. This is 9 square minus 1 minus b square. So b square is nothing but 4 square. This value is 16. This is 4 minus 3. The value here is minus 1, and 3i plus 4i, the value is 7i by minus 25. If I take minus common, this will be 1 minus 7i by minus 25. If I cancel this one, so we got the residue value. So the residue value of f of z at point z is equal to here plus 2i is nothing but 1 minus 7i by 25. So 1 minus 7i by 25. So this is our third residue value. See, first of all, what we have done. See, here, the question asked is f of z is equal to z square plus 2z by z plus 1 whole square into z square plus 4. So, in order to find the poles, we have to equate the denominator to 0. After equating each and every term to 0, so we got z is equal to minus 1 is a pole of order 2, and here it is a simple pole, and this is also a simple pole. Here, residue of f of z at point z is equal to z naught. The formula here is 1 by m minus 1 factorial into limit. So, this value is limit z tends to z naught d by dz power m minus 1 into z minus z naught power m into f of z. So here our order value is equal to 2 and our z naught value is equal to minus 1. And after substituting and after using u by v rule for the derivative and after substituting the value of z as minus 1, we got the value as minus 2 by 25 for the pole z is equal to minus 1. And next one for the pole z is equal to minus 2i. For minus 2i, the formula here, as it is a simple pole, the formula is also so simple. Limit z tends to z naught, z minus z naught into f of z naught. And after cancelling z plus 2i from the numerator and denominator and substituting minus 2i in place of z. And after calculating, so this is the calculation which you have to practice. And here the value of the residue value here is 1 plus 7i by 25. And next for the third simple pole, for the third pole, z is equal to 2i. For z is equal to 2i also, the same thing. The formula is also so simple. Limit z tends to z naught, z minus z naught into f of z. And therefore, if I cancel z minus 2i from the numerator as well as denominator and substitute z is equal to 2i, and after calculating, so this is the calculation which you have to practice, and this is 1 minus 7i by 25. This is how we have to solve. This is so important, so simple, and definitely you can score more. Please go through the playlist. There are so many videos uploaded, and please, it will be very very helpful for your preparation, and pass it on to your friends. And definitely I'll be with some more videos, and please look at those. Thank you so much.